It's fine.
He's enjoying the class.
She's double.
Okay.
Doubling the class.
So this is the last session, last session. And thanks for and it has been a good, very hectic journey with all, so many things packed up, very packed up together. So what we are going to do now is just have a review of the things that we have done so far, and we'll see how how we can essentially, given an unknown problem or a problem, we can try to come up with solutions which are on blockchain that are secure and efficient. Excuse me. Okay, so do we go with this first and try to see how to solve such problems, or do we go with the review of the course? Okay, so maybe we can just start with trying to do a course review, and then we will come to this problem, because then you will have a better, you'll remember things better. So okay, the first thing that we essentially studied in this course was, why do we want a blockchain in the first place? So any answers? Why do we want blockchains?
Secure, privacy, trust, immutability, transparency.
Those are the properties.
To secure data.
To secure data.
To
Store data.
To make secure transactions.
Make secure transactions.
To make a Bitcoin.
Anything else?
Store records.
Store records, yeah. But blockchain store, I could also store in my disk. Decentralization. Yes, we want decentralization. We want decentralization when we are storing this data. So that's very important. Okay. And then you can say that, yes, decentralization along with privacy. And we want to store records. We want to store data, everything. So essentially, it is nothing but a database, right? And it's everywhere. It's distributed. So decentralization is the first thing that blockchains provide. It's very fundamental concept. Security, as you said, security. And then the other thing is transparency. Why? How do you achieve transparency in blockchains? Why is it transparent? Pardon? Trust.
Peer to peer.
Yeah.
Every copy is available on every.
Yeah. That's true. So trust. It is transparent because we need transparency to improve the trust. And how do we achieve trust in blockchains? By keeping the processes transparent, because we are recording everything. Keeping the data in a peer-to-peer network where you can observe what is happening, what everything is on in a in open, and nothing is you can see what is happening in the network. So that ensures transparency. Okay. Anything you would like to add? Why blockchain? Any other features that come to your mind?
Activity.
Huh? Yeah. We are coming to that. So what is a blockchain? What is a blockchain?
The ledger.
It's a ledger. It's a database. It's a database. And then what are the properties of blockchain? I mean, specific properties. When we say that it's a ledger, ledger can be any ledger, right? Immutable. Immutable. Verifiable. And and and
Chain of blocks which stores the data, which records
Yeah.
the data.
right. Anything else? Distributed. Yes. Yes. So it's not just any database. It's a distributed database, and where you can verify what is happening all along. And it is also immutable. So it's distributed, immutable, verifiable ledger. So what are the main ingredients that help you to make it immutable, immutable, as well as distributed and all? What are the main ingredients that help you to main components? Or I said main things to keep in mind when you are to build a blockchain. You need to have consensus. Why do we need consensus? Huh? Why do we need why?
The record is created in 280.
Huh? The record is louder.
Records. So record is created, it should be stored, cannot be edited.
Yeah. What's that property called?
Immutable.
Immutability. Yes, immutability. So you need you need to have immutability. It has to be immutable. And then you need some consensus. Consensus for what? Yeah?
For validating the
All the nodes mutually agree on an agreement.
Right, exactly. All the nodes agree on something, agree on the state of the ledger. And what? Huh? That is a type of consensus. That's true. That's true. But consensus is important. What else do you need in the blockchain?
Solve crypto puzzle.
Solve a crypto puzzle. That is also to achieve consensus, right? Good. Proof of stake.
contracts.
Maintain contracts. Maintain contracts. So essentially, your main ingredients is that you need your consensus algorithm. You need to ensure immutability. You need so you want secure. You would like to have security in the system, and then one thing that you would need also is the yeah, you need cryptography to ensure immutability. And then you also need ways to incentivize nodes, because it's an open network, right? Anyone can join. Why will they join, right? They should have some incentive to join this network and contribute to the network. So very important thing is incentives. It should be given incentives to do some things. So it's very important to have incentives. And you would see a lot of cryptography in this, and then distributed computing. It's not computing, and a bit of game theory, and mechanism design that can help solve not just the crypto puzzle. They're designing an incentive mechanism so that everyone participates fairly in this system. Okay, so we did do a bit of cryptography in the first class, I think.
Yes.
That is very useful. And what did we learn there? Art of secret writing. And what did we learn? Did we learn anything? Huh?
Foundations of cryptography.
Foundations. What foundations?
Keys.
Keys. Encryption. Yes, encryption. We saw what is encryption. decryption, and then
Types of cryptography, public key cryptography.
public
Private key.
cryptography is
Private key
symmetric key, yeah, and then hashing. Yes, we learned about hash functions. Anything
Digital
else?
signatures.
Digital signatures. And anything else? Anything else?
Nodes is a part of cryptography also.
Yeah. What else did we learn? Huh? We also saw how commitments are really important. Does anyone remember? Yeah, commitments are hiding. Anything? Okay, no worries. So we did learn about symmetric and public key cryptography. We talked about signatures, hash function, commitments, all these things. Yeah, so we did a bit of cryptography. And then we talked about consensus algorithms. So what are consensus algorithms? You just said, will you repeat? What are consensus algorithms? Those are types of consensus algorithms that we have done. What is consensus once again?
All the nodes need to agree on the same agreement.
Yeah, so you have to agree on the same thing. Yeah, same either the same decision. You have come to the same conclusion. And in the case of blockchain, what consensus do you want? Like what do you want to agree on?
Code, contract, smart contract.
You want to have the same smart contract being deployed by the same nodes, what's also called good. You want to come together to say that it's the same block that's in all the present in all the nodes in the same sequence. And then you also want to ensure that the state is same across all the nodes, right? It's not that the state is something in my node and the state is something else in your node. So consensus becomes really important for blockchains. And what sort of consensus did we study? What sort of consensus did we do? What are the consensus? What consensus algorithms did we do? Your consensus algorithms should protect against double spending. But what are the algorithms?
Proof of work.
Ethereum is a blockchain. What consensus algorithm?
Proof of work.
Proof of work,
stake,
proof of
delegated
stake,
proof of
proof of
stake.
stake, yeah, delegated stake. So these are things that we have studied in the, while thinking about the, while talking, when we talked about consensus in blockchains. And could someone say what is a proof of work? What is it? And where is it used? To do what?
Shows that the we're doing mining on Bitcoin currency.
Transaction is
So in order to do that, what will you do? In order to show that
keep
there
records in the blockchain.
keep records in the blockchain. And what is proof of work?
During Bitcoin mining, they are doing some hash functions.
Yeah, exactly. So you are you're computing this hash function. You are doing some computation which can prove that you have done the work. And in the case of Bitcoin, it is calculating hash function many times. Why do you calculate hash function many times?
Because of machine chain connectivity between.
Yeah. So why will you calculate hash functions many times?
Whenever the block is ordered, we should need to calculate in the hash functions for connectivity between the previous blocks.
Yeah, do you need hash functions for that? But proof of work, You need hash functions to have that connectivity, or you want for the immutability. That's where you need hash functions, definitely. For proof of work, why do we need hash functions? Integrity, fine, but in the context of Bitcoin, why do we need this proof of work, and what does this proof of work look like? Remember? No?
To mine.
Yeah, so to mine. But why? What is proof of work? Proof of work. Why am I doing this hash computation many times?
And to verify the accuracy,
Accuracy of what?
transactions.
Not accuracy of transactions.
Validating.
You're validating. What are you validating?
And there was the formula R something M or.
Yeah, you're right.
That's what I forgot.
Yeah. So essentially, you're solving a puzzle.
Brazil.
That is the thing. You're solving a puzzle, and the puzzle takes time to solve. That is the proof of work. In this case, a proof of work is that you are computing you're calculating the hash of the block such that it is less than some value, difficulty level. But the main idea is that you want to ensure that the hash, you're being able to solve a difficult problem or a puzzle. Okay, so that's about the proof of work. And so proof of work, what is the good thing about proof of work, and what is the bad thing about proof of work? What is the good thing about proof of work? Or what the bad thing about proof of work?
That thing is a resources computation.
Yeah. Computational resource, you have to, it's kind of wasted because you don't get to do any constructive work. You're just solving puzzles. And one thing is for sure, if you have done a proof of work, it is very easy to verify whether it is correct or not.
Yes.
But the problem with proof of work type of problems is that it's very hard to, it's very computation intensive. So we don't like that. Okay, so you have done the proof of work, and then what else have you done in the consensus?
Proof of stake.
Proof of stake. What is proof of stake?
Validating.
Huh?
Validating.
Validating. No, you have to tell the full sentence.
Users which have more stake, they have more to say and maintaining the system. Kind of this is-
Yes. So proof of stake, main idea is that if you have more stake, essentially you have more say, and that is why you would be given, you have higher probability of being able to propose blocks, right? So that's the crux of the proof of stake protocols. And how does Ethereum, we talked a little bit about Ethereum, the earlier proof of work versus proof of stake, and now it's proof of stake, and we also discussed about how proof of stake is done in Ethereum, right? Okay. Do you remember any of the attacks on the proof of stake? What are the negatives of proof of stake?
Double spend.
Double spending. Okay. How does Bitcoin prevent double spending?
It makes a fork and then the longer length of.
Yeah, you choose one of the forks. If there is, there are two for, the forks, you choose one. And it has been done twice. It is not confirmed. It's not put in a block. There are two transactions. Alice makes two transactions to Bob and Carol. Only one of them would get in on the blockchain. The other one will be discarded, right? And this sort of proof of work is not only present in Bitcoin, but it has to be guaranteed in all blockchains, because and all blockchains have their ways to resolve such forks and so on. So that's one thing. The other thing is that for the proof of stake, you do have you have to consider the You do have some attacks on the proof of stake. Do you remember any of the attacks? Huh?
WannaCry attack.
WannaCry attack. What is WannaCry attack?
It was some cyber attack
Hmm?
by North Korean hackers.
Yeah. Then what happened?
Like they used to lock the PC of the victim and they used to ask for crypto.
But how does it relate to proof of stake? Okay, you remember that. Okay, that's good. That's good. That's good. You remember an attack. But with the proof of stake attacks, anyone remembers proof of stake attacks? Some proof of stake protocols? Huh?
That is not network attacks.
Huh?
No.
DOS attacks, did you say?
I refer notes.
DNS.
Huh?
DNS attack.
DNS attacks. Oh yeah, you have a lot of these attacks that
Confused with the IoT.
yeah.
Yes.
Those are yeah. Yeah, what are the attacks? Because yesterday, ma'am also talked about many attacks, right? Do you remember any of those attacks? Huh?
Eclipse.
Eclipse attacks. What is Eclipse attack?
When they corner two or three isolates one.
Yeah, so essentially they isolate the network. What happens if there's a net Eclipse attacks? If there's an Eclipse attack.
Did they isolate network or a node?
Huh?
Did they isolate a network or a node?
Yeah.
It's, like
You could isolate one node, but generally it's a part of the network is isolated. What happens if there's an Eclipse attack? What will happen if there's an Eclipse attack?
Malicious nodes are isolated.
Hmm.
Neighboring nodes like.
So the group of nodes is isolated. What is the implication? Why? What will happen there?
The malicious or
Compromises is incoming and outgoing traffic.
Yeah. It compromises incoming and outgoing traffic, which means what? So essentially, when you are broadcasting, it does not reach many of the nodes, right? So if you have a network which is malicious, it is the one which could actually, not broadcast to everyone, and they might be able to generate blocks which are within the network, and they can get more support, and therefore they can really, have, and they can override the opinion of the people of the nodes which are not connected to the main thing, which have been partitioned. And if that happens, what will happen is that if there is if the votes are on the bad blocks, then it keeps on growing. So that is what it just changes the course of action or course of the blockchain. So that is why we should actually protect against this Eclipse attacks. Okay, anything else you remember? Proof of stake. Nothing at stake.
State attack.
What is nothing at stake attack? So
The
people,
attackers can create multiple blocks.
yeah, exactly. They will keep on mining because they know that I have nothing to stake, I have nothing to lose. So they will keep on mining, and they will keep on adding the blocks. However, they're not contributing anything, right? And they're just building more blocks on the network on top of the ones, and have more confidence that yes, this is a valid chain. And how you can protect against this nothing at stake?
Penalty.
What penalty?
You said something.
Introduce penalty.
Yeah, finality. Yeah, finality means like you have to make this. Yeah, you have to ensure that the block has finality. But my question is that if you have this, um, nothing at stake problem, so it just goes on adding blocks, what will you do? How will you prevent that? How will you do that prevent? You can essentially do one thing. If it is an invalid block, it can just it will be penalized, right? So you have to penalize the bad actors, bad nodes who are just doing nothing, right? So these sort of things are available, have to be ensured in the consensus mechanism. Okay, any other attacks on consensus, proof of stake consensus?
Binding attacks.
Bribing attacks, yeah, bribing attacks. Binding attacks, what is binding attacks? Binding or bribing?
Grinding.
Grinding attacks, grinding attacks, grinding attacks. What happens there?
Minus the create blocks. I know only like they recreate blocks in this attack minus.
They recreate blocks. What happens then? Or? Okay, think maybe we can come back later and ask the same question. Okay, so proof of stake. Yeah, pardon?
Long range attacks.
Long range attacks. What happens in long range attacks? What happens in long range attacks? So you can go back in history and try to change.
Rewrite history.
Huh?
They rewrite history.
Yeah, they can rewrite history by influencing the nodes who had high stake in the system. And you can prevent this by checkpointing. So after a point of time, you will finalize, so that you can never write history after a point of time. And back in the you cannot go back and rewrite history. So that's one thing. Okay, so you have many attacks on the proof of stake, and then we also saw proof of delegated stake, in which there's not one party who is staking, but it is collecting the stakes from multiple users, and then they have to also distribute the stake amongst them. So that's a good thing. And then in general, we had some of the other things. It is proof of history, proof of authority. There are many things actually. Proof of storage. Proof of storage is something that says that if I have enough storage, that's how I can show that I'm really so the more the information, the more data that you store in the network, the more is your say. So essentially, it is similar to stake, where you have to stake the stake on the chain. You are essentially saying that I have enough storage. I'm contributing to the network by giving my storage, by contributing storage to the network. So this is another thing. And there are other proof of X as well. Okay. So next, what we did was scalability of blockchains. What is the main challenge in scaling?
Scalability will reduce the security.
Yeah. So you did talk about the trilemma.
Triangle, scalability, security, and another.
Decentralization.
Yes,
I'm glad that at least you are remembering the things. Honestly, this is nice that collectively You are looking, right? But did you get all the things, right? You have received, right?
Yes, ma'am. Yes, shared it.
Yeah. So yeah, so the main challenge, why are we facing scalability issues? We are facing scalability issues, which is leading to energy. Yeah, we have scalability issues, and yeah, we do have energy, costs. If you are using a proof of work, that's a big concern. But apart from that, why this is scalability? Because you are running some consensus which are, which is you have to, because nodes can join anytime. I'm mostly talking with the permissionless. This permissioned blockchains that I didn't essentially talk at all. And the reason being that, many of the permissioned blockchains, these are something like maintained within the organization. So there's not much to consider in terms of these very interesting features that blockchains enjoy. Okay, coming back, scalability there are scalability issues because nodes can join anytime, right? And they can participate in that network. And you have to, if you look into the when a block is generated, it has to be broadcast to everyone. They have to come to an agreement. It's not very easy to do all this, especially when there are so many nodes in the network. And that is why scalability is a big problem. So in order to address that, what did we do? What did we suggest? There are many ways to consider, take care of scalability. What are these? Huh? What? Layer 1, layer 1 scaling solutions. What are layer 1 scaling solutions? What can you do? Layer 1, layer 2. Layer 1, you can improve the consensus. You can improve the consensus algorithm, and having better consensus algorithm can really help scale. But the other one was also layer 2. What are layer 2 solutions? Huh? Yeah. Okay. Yeah, above that layer 2. But what is layer 2 again? Off-chain transactions. Off-chain payments, off-chain transactions. And what do? You have to ensure that when you're doing off-chain transactions, whatever you write after the transaction is done, essentially is a succinct representation of the things that have happened off-chain. So it's a short representation of what has happened on off-chain. If someone makes a dispute off-chain, then you have a dispute resolution strategy. So that's something we have learned in, while we were talking about scalability. So why with scale, we've talked about the payment channel networks, we talked about the roll-ups. Both are off-chain solutions, and we had a long discussion on side chains, right? Did anyone go back and follow up what we studied? Huh? Yeah, we have bridges to connect.
Side chain security of main chain is not a guarantee.
Security of the main chain is not a guarantee.
So side chains are used to making the transaction faster.
Yeah. So on the plus side, you have the on the advantageous side, these are faster. Sometimes they might be low cost compared to your main chain. But on the flip side, these do not have security at the level of the layer 1 security. So this is a big issue. Okay, and then we talked about IoT and blockchain. So what is IoT?
Internet of Things.
Internet of Things. What is Internet of Things? Because after this course, you know, everyone will when you go back to your,
Unconnected.
yeah. So when you go back, the first thing people will ask you, oh, you have gone to chain of things, blockchain, IoT. What is blockchain? Can you tell me in one word, in one sentence or two sentences? Like you have met your friend, the first thing, and then, hey, you went there. What did you learn? And then you will say, I learned IoT, I learned blockchain. Oh, what are those? And you have to say in one sentence, very nicely. Yeah, this is it. So what is that one sentence description?
Distributed data.
Distributed database.
Decentralized.
Yeah, and then And then IoT. What is IoT?
Connect and connectivity.
Connected what?
Connected to unconnected.
What? Connect to?
Unconnected.
Connect the unconnected.
Connect the unconnect. Okay, connect the unconnect. Yes. And then, connect the unconnect. So what are you doing in IoT? What is connect? What is connecting what? The unconnect. What is unconnect?
Different type of
Processing the sensory data.
Many types of devices are there. It can be sensors. It can be your, RFIDs, tags, and phones, or So all these things you are connecting them together, and to achieve certain tasks. And then what else?
Processing the data.
Processing the data. So in fact, IoT, Internet of Things, they consist of a heterogeneous devices. They are connected together. Some of the devices are very resource constrained. Some of the devices are, they have a lot of resources. So it's a mixture of devices that are connected together seamlessly. And why do we study these blockchains? What is their use? Why are we doing all this 5 days of Gyan course on IoT? What?
to prevent the single point failure.
So yeah, you have many devices. You have a distributed kind of an approach. You can prevent the single point failure to ensure trust. What else is there in IoTs? Can you give some examples where IoTs are used?
To store data.
To store data, yeah. But anything can store data, right? Any server. Then why are we using an IoT?
Because of trust.
Because of trust.
Transparency.
Transparency. Not all IoT devices are transparent.
You're getting the data from IoT sensors and using this data in blockchain.
No blockchain. I'm just talking of IoT first.
Only the IoT data.
For wireless connection.
It can be wireless. Yes, it can be wireless. Yeah.
Predictions you can.
You are using IoT to do predictions. In what way?
Rely on the data.
So essentially, maybe that's right.
Security.
Huh?
Security.
Huh?
Security, man. Security. Privacy, security.
Yeah. So essentially, suppose you have some sensors and you're collecting some data and you want to making a prediction. Yeah. And then
Controlling any home automations.
controlling home automations, for example. And what should IoTs have? I mean, what are the properties that the IoT networks should have? What are the properties? What properties should such networks have? Range. What is range? You cannot tell one word answers. You have to explain it a bit. What is range?
Quick range of access.
Huh?
Quick range of access.
Quick
networks.
range of access networks. Okay,
Remotely access the things.
you can access remotely. How could you access remotely? What are you accessing remotely? You're right, but you have to explain. What are you accessing remotely?
Any device.
Any device.
We are accessing what we need to access.
Yeah.
That's what we need to access. There are many things that.
Yeah. So tell me where you want to access some device remotely. Can you give some scenarios where you want to? Huh? Smart refrigerators, smart homes,
Laptop.
laptop,
Smart lighting system.
lighting systems,
Many
agriculture,
CCTV cameras.
CCTV cameras, security
In
cameras,
bikes, in bikes and cars.
lights and cars. So yeah, so the thing is that how would you have said smart homes. How would you use this this smart home? So how would you access devices in the smart home remotely? Huh?
So operate from mobiles and smartwatch.
Yeah, you can sensor. That sensors could be connected to your and that information you can get through your maybe some other device. And what properties should this IoT have? One of the things that we have said is it should be distributed. Anything else? What happens, like, someone manipulates your home automation data and then your fridge is not working? Huh? What property would you need? Security. It has to be secure. The IoT system should be secure. Very important. What else? It should be energy efficient. You don't want, I'm trying to install something, but it is just taking, I'm getting a huge bill at the end of the day. You don't want that, right? So security, efficiency, these are all things that you would need. And some of the applications of IoT that you have already seen, so smart homes, then you said agriculture, healthcare. So has anyone ever worked with, anyone worked with some applications in IoT? Huh? You have? Yet to. Yeah, okay. And now blockchains. What role does IoT? Blockchains have to play with IoT.
Storing the data.
Storing data. But blockchain, IoT data is a lot of data. You cannot store it on chain. It's very hard to store IoT data on chain. What will you do? That's a good question. You have a lot of data and you cannot store the data on chain. What will you do? You'll go off chain. And then what is the use of blockchain? If you're storing off chain, how would you?
The IoT data are encrypted and stored in the blockchain securely.
You cannot store a lot of IoT data. IoT data is a huge amount, could be a huge amount of IoT data, right? Depends what you want to store. But if you want to store all the sensor readings on the chain, then it will become very, very large. So what can you do?
But to access the data anytime.
You can access the data anytime, but you're storing it somewhere else off chain. Then what is the connection on chain? What is the connection? How is this connected to on chain? The off chain data, IoT data. Yeah, we'll come to that. Yeah. Through bridges. Yeah, so essentially what you do is not even all that difficult. I mean, think of it that you have all your IoT data, you store a commitment, which is a very short commitment on the chain, and you store the rest of it. Now, if anyone tampers with your IoT data off chain, then the commitment will not match with your commitment on chain, and you can figure out that there is some corruption, some data has been corrupted, right? You can do that. Anything else? How you would, what exactly will you need for IoT applications? You need storage, definitely. Anything else? Can you give certain other scenarios where IoT could be used on blockchain? I can give you a hint in supply chain, for example.
Traceability.
Huh?
Traceability.
Traceability. So you want to have a shipment and you want to trace it from the time it was, manufactured by the manufactured in a company to when it was delivered. You can essentially have a. How will you trace? How will you trace? Huh? Louder. You can have a barcode. You can have a barcode, and then maybe you have an RFID reader with which read the barcode and put this information on chain to track it or to trace it to where it came from or track it as it goes in the system. So all these things are good examples where you can use blockchains. Okay, and we talked about industrial IoT applications today, where we said that not only do we have IoT devices, but we also have fog nodes which help to outsource the computation. And so in the case of a IoT environment, you have IoT device, but the processing can be very high. That can be done in the cloud. And sometimes this processing can also be done closer to the devices on fog nodes, which can reduce the latency, which can improve the computation time and also latency, and also have more security than if it was completely outsourced on the server. So this is something we talked about. And in industrial IoT, you have like a lot of sensors, a lot of other devices, a lot of these readers, these tags, which are essentially used to read information from, and different types of sensors which are sensing different things. And as such, these industrial IoTs could be very useful when clubbed together with blockchains. Okay, so before we go, these are some of the things that we have discussed in this course. Now, what I'll do, I'll just pause for a bit and ask if anyone has ever thought, like, if I were to do, a small project, what it would be like. Now that you have done IoT and blockchain, what sort of projects would you like to do? What would you like to see? What would you like to build? Anyone? Give a problem. What do you want to build now that you have got knowledge of these two things? Learning management system. Okay, first you define what is a learning management system.
Basically, the college app in which everything comes, like the slides, then quiz papers and other information. Special information from the teachers.
Yeah, someone is talking, so listen to it, please. I want you to give attention to
me. And the grade card can be authenticated on the IoT Roper blockchain. So when the recruiter comes to IoT Roper, then he can check that the grade cards are authenticated officially by IoT Roper. So that those grade cards are not fabricated.
Okay. So I will just repeat what he said. So he wants to bring a learning management module on blockchain, which will contain all your So the learning management module, not on blockchain. Blockchain, you have to use blockchain. But the problem is that you have a learning management module. The learning management module would have all your, class notes. You have the slides, you have exams and everything. And then students would take all these classes they would write exams, they would have tests and everything, right? So you would have a system where students will take the exam, your marks is written, in which exam, which quiz, whatever, you have received what marks. And then you, after the exam, say maybe after 4 years, you are graduating, or even for every course, you are given a certificate, or you have the transcript at the end of your semester, where every component is written. And say, for example, someone is coming for placement, it should be in a way that they were not going to ask for your printed copy or anything. They will have access to your data, to your transcript. They can see what happens, or whether you have scored different marks, scored marks, which they have set as a cutoff. It could be used by recruiters. It could be used after you graduate. You will be given a certificate where your name and the university's name, when did you graduate, and other things, or your marks, or your division, or your class, or CGPA is written. This can be actually used as a certificate. So, for example, later when you are applying for another degree, say you're doing a master's or something, MBA or a PhD, you would need to validate your transcript, or maybe a company is asking to validate, show your transcript. It should be in a way that this credential is given by your university. You don't have to take it, scan it, show it to them, right? Did I say things right? Correct?
Yes,
Anything I missed?
No, absolutely right.
Okay. So think of this application. How would you design it? Okay, 5 minutes. Think. Then we can start thinking of the modules. I'll sit. 5 minutes. Think. And first of all, how would you do it? Without a blockchain, can you do without a blockchain? What new features can you bring with the blockchain? Think. You can discuss this time. This is not an exam. So think and discuss. If you want, you can discuss with your... So learning management module, and something you have to tell me something which will distinguish your learning management module to whatever is available nowadays. Okay, maybe I'll ask you this question. So now all that I said is fine, right? You have got all these things that you are already in the management module. Now, the question is, give me at least one property this management module should have that is generally not present in other management modules. 1 or 2 properties that will distinguish your management module. Say, for example, you have designed a module and you want to sell it. Look, I've designed a new management module. You will go to universities and say, look, this is the one that I've designed. And this has some very nice features. What are the nice features that you would like to have in that management module?
Decentralization, maybe a feature.
And then people will ask, why do you need decentralization?
To maintain trust.
To maintain trust. Anything else? Okay, you tell me, you want to build a management module. Do you have anything in mind which will distinguish your management module from everyone?
We can add a doubt solving forums.
Doubt solving forums. Okay. Anything else? Anything else?
Currently, I can access people. We can check where it is currently. Who is need to be signed. We have that in place.
Some of you are just sitting like that. You are not even thinking. You are the back. You don't want to think, or you're thinking in your mind. Thinking, right? What are you thinking? I mean, all of you. I mean, anything that will say any feature you want in your blockchain. Maybe first, before you design, before you start with your design, think what's new that you can bring in.
We have another project in my college now. We want OD means I have collect and sign in HOD and staff here in charge in some four kind of department heads to get that sign. We want to create one application to request an OD and he get signed in digitalized and then I'll check digitalized means I can check okay my OD is verified and get OD. It means in my college to get a paper receipt and search the stuff and get a sign. It means can make time and to get that OD now in this application to make easier to get OD. Chance.
Yeah, I like that thing as well.
And then the OD process will be verified in the person can like my HOD ma'am will be verified and then get a OD. It's not a verified all management stuff. And who person can take OD? It will be all are digitalized in the system. Any who can get a OD? So it's a name list on the data analyst.
So, for example, you have come to this place, right? You needed permission.
Yeah.
So, you have 3 or 4 people who would sign, right? All you want to do digitally, right? And you also want to make sure that, that for any sort of request that you do, you also know who is the authorized person to sign within the system. That's also nice. It is going to save you time.
Yes.
Good.
No,
So this is a project that you will do after learning, going back.
okay.
Yeah, because it will help you to really understand all the concepts that you have learned. Okay, so now you have many students in this class. So we have got 2 projects. One is a learning management module, and this the process management. Okay, first of all, this is again a question. Why do you want to do it on blockchain? And similar question to you. Same question to you. Why do you want to do on the blockchain?
In the project will be the output will be certain. In future, who can take a OD? That's there.
What is OD again? Sorry.
On duty.
Huh?
On duty.
On duty.
On duty.
On duty.
Even when you're off
It's
campus,
mean-
you'll get attendance.
Off campus to attendance means.
Yeah.
can
Okay,
do
got it.
OD letter.
Okay.
Students may cheat.
Yeah.
Writing OD, they can sign on the
Yeah.
paper.
Yeah, OD in one day. It's cheap means database can check the OD.
Right. Okay. Yeah. Good. Yep. You can cheat anyone, can just sign your OD. You can only sign your OD and take it, right? Submit it.
Anyone can sign.
Mm.
In the letter, anyone can sign and given. I got the sign in HOD ma'am. Given take attendance, but in this place, HOD ma'am can get access to verify. And
For example, who is going to be give attendance, they can open the portal and verify whether this person currently on duty or
Yeah,
not.
all this is good. Now, both of you, or I mean, all of you, this question is, why do you want to do it on a blockchain? These are good, nice applications, extremely good applications. Why do you want to do it on a blockchain? Huh?
This changes. They said you are not doing something complaint raised against me, which I had show by the database. I had a verification or authorized by your sign. Digitalizing.
That I write. That is fine with me. You are signing. You're digitally signing. Very good. Question is to that question that I mentioned yesterday. Why and where, when and when not to use a blockchain? Do you need a blockchain?
There are no, for example, this is the first application we have made for OD, one first to undo T. Okay, that is creating as one node, like a black.
No. The question is not how you will do it. Question is not how you will do it on a blockchain. Why? Because you are proposing a new thing. Everyone will ask, why? Why do I need a blockchain? This is the first question. Then they will ask, okay, how are you doing? And you will say, like, it is estimating, it will reduce the process. I can think of an OD, normal, centralized OD. What is wrong?
Transparency. When another shop can check as per signature OD. Transparency to data. The blockchain will be used in transparency. In the shop, normal shop will be checked. The student can be take OD in today. Check. This is called transparency to use blockchain.
Transparency. Okay, you want transparency. Can I ask you one question now? You will tell me, so this is how I do things with my students, okay? They give me proposals and I try to find faults in their proposals. So they will give me one, I will say, no, this is not going to work here. Then they will give me another, I will say, no, this is not why it's going to work. And in this interaction, it's very important, that we ask this question. So when you are asking, you will say, why? Why are you doing this? Okay, so that's the exercise. And every time you have to really think hard to find a problem with his approach. Only then you are essentially thinking and coming up, and you are coming up, both of you are coming up with a nice solution, right? So, yeah. First of all, solution. First of all, problem. The problem here is that you have everything. I like your problem. Honestly, I like your problem. It's definitely going to save a lot of costs. The only thing I don't understand why you need a blockchain. No, that's fine. Not knowing is fine. You will think if you really want to think. So the first thing is that in this proposal, the need for transparency. Do you need it to be transparent? For example, everyone will come to know that I have been to this, IIT Ropar to do a course, but I've also gone to Shimla or something, or whatever, or just that. I mean, everyone is able to track you, track what have you have been doing and what have you been doing. So anything that you want to, do you really want to make it transparent? If you want to make it transparent, to what extent? And can you still write on the blockchain and make things hidden from people?
In the authorization only I have written from people. Only verified are not only transparent. And otherwise all are hidden.
All are hidden. Okay. Now I still don't understand why you need a blockchain. Also for LMS, the learning management module. Learning management system. Yeah. Why do you need a blockchain?
Because you need to authenticate the data. And blockchain is more about the community. So learning is also a peer learning thing. So that thing will work better on the blockchain. Because many a times in official learning.
Okay, I am asking a question and he's trying to respond. Yes, sir.
I mean, many a times in learning management system, the slide comes straight from the professor. So if a student has a slide, then he can upload it. And there can be a like to dislike ratio thing to check whether that slide is useful or not.
So why can't you do it in a normal centralized system? You can get permission to upload your slide. anyone can get a permission to upload the slide. Why you need to do a blockchain?
I think there is a centralized authority, then that person has to admin the whole thing. But if it is on the blockchain, then everyone will admin each other, and trust will be maintained in the system.
Huh? Immutable, yeah, immutable. Is everyone convinced that this LMS would need a blockchain?
No.
Okay. If you say no, then you have to say, you have to tell him, this is what I don't agree.
I don't think we need blockchain for small applications.
Small application.
Like it's gonna be majority of like 10,000 of people, that's all. So you won't have any outside transactions or anything. So I don't think we need blockchain.
Okay, can you achieve the same thing without a blockchain?
Yes.
How?
By just having administration.
Admin
Can
what?
verify. By
Administrator.
giving access to few people who can verify, and they should be responsible. So we can achieve something like that.
Yeah, how do you? So who will be the people who are responsible people and who are not responsible people? No, the thing is that what I'm trying to make you think is that there are different questions we need to answer. Trust. Okay, the one other question. So there is another question over here, which is also no, you will answer, but I want to first know from others. Do you agree that this OD application needs a blockchain? Yes. Wow. Then I think this is the problem, at least for you guys.
This can be unchangeable website, ma'am. It is immutable. Can be
transparent to everyone.
Transparent to everyone. It is immutable, which means I have applied OD, which can be verified. It means it's not changeable. Changeable means anyone can change, not verified. It's not
cannot be applied. No.
Verified means always verified. It is the immutable. It can be a blockchain.
It has a transaction. First the class in charge verify this document.
And here in charge
forwarded to the here in charge. Here is the forward to the work for the in charge.
It can be a chain linked IoT. One by one can be verified.
No, I agree to everything. Is there a single person who says that this can be done without a blockchain?
No.
Maybe.
Oh, you have got a majority here.
It is immutable means this
You
is
guys, the last, yes. Wait. Yeah. Okay. Yeah. So the problem that that's OD problem, if I understand correctly, is that you would raise a request that you are going off duty, and this has to be approved by a few people. Firstly, your class teacher will approve, then maybe your head of the department will approve, and then the university should approve or something. And every time you really don't, okay, so this is the first thing. You don't want you want it to be digitally signed, and every step when I'm looking, I'm signing, so I am the first step, I have to ensure that this is a valid authentication, a valid document. And then the second person, the first person who signs has to approve it. The second person who signs sees the first person has signed, only then it will approve it, and then it goes down. So you have like 3 or 4 approvers. So everyone has to agree to finally be able to get that approval. In the meantime, the system, once, so a person who's submitting the approval for approval, they might not know what was the process, or who is the right, who has a right to approve, who has authority to approve. in that case, they would have a list or a designated person whom they can who has a authority to approve. So this document goes to that person, and then so on. So essentially, there's a list of approvers, right?
Yeah.
Who chooses the list of approvers? You or the system?
System.
System will choose. Okay. So for every document, you will have a system. The system would choose the approver, and then they would do it.
The list is of the hierarchical people that they are going to approve one by one.
Yeah, one by one. Okay.
So I don't think that we need a blockchain.
Yeah. Okay.
Like if you can submit your form, and the first person who is going to approve, we can keep the flags on them. Like if he submitted this, and the second person who is top of him, he will only get that request after the first person has approved it. So it's very simple. In like we have made a SD, like we both have made a website of this approval kind of thing only, like a course instructor kind of thing. We apply for a course, the course instructor applies it, and then the faculty advisor will approve after the course instructor has applied it. So I think that I don't need blockchain.
Okay.
After the completion of the
And we can do this without blockchain, man. If you use blockchain, it will be much better.
Ma'am, I don't understand the use of blockchain in this.
Okay. Yeah. So good. I mean, this is what I wanted to hear. Okay.
So this is basically a brute force approach. If we want to improve it, we can, but
yeah, we can use
but it's not as necessary as
Not required. Okay. Fine. You have another answer?
In this, we have 3 people, ma'am. They said 3 people are in the authority is there. So we don't, and what happens actually is the person who is in the top authority don't even sign. We have the seal of them in there, and so I think this will create a big workload for them to constantly check the on duties, and again people will fight, and this will only create a conflict.
Yeah, but what he says is that it's automatically done, right? You don't have to take a paper or something. It is automatically done without even a blockchain. So do you need a blockchain? You have to argue.
Yeah.
You have proposed.
It means in the application when we completed, and it can be another time change it, not change it. This is called immutable.
Science of the
It can be blockchain is not available.
His point of view, anybody can interact,
Okay.
Interfere. Don't interfere.
Good. It's going well now. Okay.
like they are saying that anybody can approve, but it is not necessary. Like when you are logging in, then you are doing the authentication or authorization. The only person with that particular ID will be able to approve that. Like a course instructor, he has some ID, abc.@gmail.com. So whenever he logs into them, then his what we can say, his role is defined with that ID only, and it is stored in a database. So that's what I'm saying.
What if the
What exactly are we?
what if it's hacked and the data is
We are approving a request. Yeah, you can ask more questions because I have more questions. Yeah,
Like online request.
Huh?
Like online request.
online request. Okay, so someone says that the database can be hacked.
Yeah, it can be. I'm saying that we can use blockchain in this, but I don't think that it is as much as necessary. It's not that a sensitive topic, like you are approving something. So that's what I'm saying.
This is the sensitive topic. Not in the attendance particulars. It can be merged in the. Yeah, man.
No, ma'am, I am saying that
Otherwise, pay the 2,000 bill.
I am saying that
Yeah, man. Per
nobody will.
person can attendance will be.
No, this is an important problem. No one denies this. No one denies this. This is a very important problem.
I am saying that nobody is going to make that much effort in hacking into a database which have attendance only.
I know hacking.
We can do
Cyber security department can easily hack.
And he won't come to college. Attendance also must for college.
Okay, I have one question in all this.
Like you cannot just hack into database. They are also know that fragile.
But what if the IS most of us get below?
The zero possibility is very create that.
If data has so easy blockchain, then database means it is beyond comparison with any other database. If your database can be hacked, then leave that database and shift to something else. I would recommend you shift to something else.
So the thing that
can be hacked.
they are saying is that you need a secure implementation that is separate problem. But the question is that whether you can just do with a good secure implementation.
It's obvious that blockchain increases the security of this particular infrastructure. But if we ask that is it necessary?
Yeah.
Then it's not.
Like
It's as easy as
it's good to have feature, not to like necessary.
Necessary. Okay.
we can obviously increase the security of our infrastructure, but it's not necessary.
Like it's saying that we can use blockchain in everything. Like
Yeah.
You
Yeah.
want blockchain in everything.
No.
That's what I mean.
These are the things, So when you're building a blockchain, whether it is really important, really necessary, this is the first question to ask. Okay, I have one question for you, and maybe for everyone. So this is I'm in favor. I'm giving you one more feature, okay, to justify why blockchain would be useful. But again, you will still counter. I mean, this is what I really want. Okay. So at this point, when this OD comes and you check, right? You check, well, and you say approve or disapprove.
Yeah.
What if it should not have been approved and I approve it? Is there a mechanism to check this? Or is it as a whims of that person? It's a whims of the person to say, yes, it is, I'm approving it or I'm not approving it.
I don't understand.
Okay, so you have OD, right? And I go to my class teacher. I say, approve it. Why will he or she approve it, and when will he or she disapprove it?
Ma'am, in the input form, always description tab only have the meaning of
What we are to do.
Right.
For what purpose?
Right.
is the work?
Exactly. This is what I'm asking. That the person who is looking at your form essentially reads with your description or your purpose, right? And it has to be a valid purpose, right? Okay. So how would you still, it's not a blockchain problem, but it's a problem like, definition of your problem is, could there be a mechanism to approve or disapprove a form depending upon, the description or, or the other things, so that later you cannot come and say, my head of the school, just rejected it for no reason. Could you think about it? That is a feature. That is a selling feature for you.
If the description was valid, they will upload.
How will you say the description is valid? How will you map? What is your reference? Keywords. Keywords.
Attaching the proof.
Authority can be disapprove can type a reason.
Yeah. So, but again, you're adding cost. I'm reading it. I'm thinking what to add and so on. Right? You're removing the paper cost, but can you make it a bit better? Your problem definition. Then we'll think whether it's a blockchain problem or not. A little bit more. Refine your problem a bit. Okay, that's fine. But this is.
I think there are just try to categorize OD based on different things. For example, we got OD for this. So for this type of things, we can use the certificate which is approved by I don't know who approved. We can use for this type, we can use this. And for ODs, we can use that day-to-day against the application. So, other than that, medical issues can be done with medical certificate.
So you are uploading a certificate along.
Yeah.
You are approving certificate as a proof.
For the proof as well. What I done.
I think online will make it more cost. Will make the cost more than usual, and also make it common.
Someone takes the certificate from the doctor. Problems are complicated, honestly. But the thing to take back from this discussion is that you might be proposing something. There will be hundreds of people who would say like you can do it better, right? So when you are proposing either the first problem, you really have to justify. So I really like it that you want to automate your system to have remove that paper-based thing for a thing. But that itself can be a very good problem for you to go back and
I have
work.
another idea for this.
Okay, no, we'll talk about the second idea, but you have to refine it a little bit, where you could possibly have this approval process more fair.
Ma'am,
You know,
the
fair.
approval process can be a little bit of alteration, ma'am. And the head of department when verified, the approval can be processed. I will go to another symposium, can be in another college, get a certificate and verify the application website, and verified will be completed, and I get a body in end of the day.
But then again, I'm asking, for all this, do you need a blockchain?
Yes, ma'am. Ma'am, the attendance percentage can be changed university topper rank. Yeah, which means the 100% of attendance having person only have 10 marks in the internals. The person can be changed and get a full mark in the examinations. It can be unfair. That means I have a blockchain to secure the network.
Okay. Anyone
I would
countering?
like to know the expense of the blockchain.
Okay. Wow. There you have. Okay. Expense of the blockchain. Now you have to justify that. I honestly don't know.
He's also same class.
Same class. That's a good thing, you know. You guys should have a good discussion so that you can really come up with,
expense can be under the college management.
Pardon?
The expense can be under college management.
No. Don't tell me that, because you are building something not just for your college. Think about it. If you're building something, it can go beyond your college.
Yeah.
If your college can pay, does not mean that another person would like to pay. So when you are making a proposition, you should be
free of cost.
No, it's not free of cost, but you have to justify that compared to a blockchain, because as you guys said, you can do it with a blockchain. You might not require a blockchain. So you have to justify. If I'm using the blockchain, these are the good things. If I'm not using a blockchain, then I have a lower cost.
High security and this is the reason of the blockchain.
Okay, I will leave you guys and you to decide how to frame it and whether to use a blockchain. But I would really want a feedback what you did after this.
Arguing,
Not arguing, not just arguing.
Argue in my mother tongue, ma'am.
No. So I want you to go back and think about this. And because you are here, you can also discuss and make something. Because then this sort of course is justified. Of course, it's justified. You are learning things and you can always use it. But every idea is now fresh, and you are having this discussion. I want you to write it up. Try to think, discuss with your friends, build it.
Yes.
And you will let me know. Both of you.
He will discuss about.
Sure, we will update to you.
No, you will. I don't want now, because you cannot build it now overnight.
Yeah. They are going to do
Surely
the final
the
project. They design it.
created and mail it now.
Okay. And you guys can also give feedback, send it to them also, because they said that you cannot do with a blockchain, and you are doing it with a blockchain, possibly, depending upon what that guy. I honestly I feel so bad. I know none of your names. It's huh? Aditya. Aditya. You have to tell him. You are also Aditya. Oh God, that's good. That's good. So decide, and within the group. I don't know if you have the emails of the rest of your team, but I really would like that if you are designing your LMS on the blockchain, Aditya, you're designing the LMS on the blockchain. Please share it with all of us, so that we also see that how these discussions have come about. And when you are discussing, you can also involve all the participants, or something. So maybe you can have a small group, which you have already you already have a group, not with your friends, with everyone.
Yeah, ma'am.
Okay, that's good. So that's good. So then you can start these things, and I want you all to participate, because this is such 5 days course, but you have come together, you have learned something together. Now it's also the time that you build something, or do something with it, with this. So I will strongly encourage you to keep this discussion on, and try to discuss among yourselves to see if it can be helpful. And you guys should also count down, that is your task, so that they can refine the things. Okay, so I think we have had a good discussion, but the main point is that when you are doing blockchain, please ask yourself, is it justified? Don't do it because everyone is saying blockchain is okay. So with that, we will stop, because you'll get the certificates now. So thanks everyone.
Yeah, we can use blockchain
I never answer. No, I will not take anyone's side.
You will be answered.
No, I don't want to answer, because honestly I don't know an answer. There's no answer to this.
Your answer will make a main project.
No, I will tell you one thing. You can go either ways, but whatever you do, you have to justify.
Yes.
Right? So I don't want to say that you cannot do. I will not say that you can do. So I will not say anything, because it's something you have to sell. Yeah.
How much is cost of the blockchain? How much does it normally cost to build a blockchain?
How much does it cost to build a blockchain?
Like average amount.
Build a blockchain or an application on a blockchain?
Application.
Both. Applications. Okay. So look, if you're building a blockchain, it's not just a matter of cost. It's a matter of. Huh? So the matter of thing is that whether it's going to be up, the people will take it up or not, because the all these price determination will depend, like how many people are there in the network and so on. So different projects have different sizes, they do different things, the cost will depend upon that. It's very, I would say, very open-ended question that you have asked me. And similarly, if you are building a blockchain, anyone can build a blockchain. But that to be able to sustain it, that is the question. Okay, so we will, I'll go and tell Professor Pal to get the certificates. And in the meantime, I would like to thank all of you. It has been a big pleasure working with you. And these are some of the students, without whom I would not have, who have really kept me going. So some of them. So when I was in India, this is one snapshot of my team. These are, some of the students in my university now. I really enjoy working with them. At the same time, I really enjoyed, teaching you this course, though it's for a very short time. And, feel free to reach out to me if there are any questions. And we do have always open positions at our universities for people who are really interested in Sydney. And UNSW is one of the top universities. It's a very good university where a very supportive environment and everything. So yeah, I mean, most welcome to be in touch, and I would really like to see that some of you who have learned this make good use of it. Okay, thank you very much. We'll wait, please, and we'll go and ask Miss Professor Pal to come and give the certificates. Okay. Oh, hold on. Huh? What? Nandri. Nandri. And what is welcome? How will I say welcome? Vanakkam. Vanakkam.